So now the next speaker is David Champion from GA, and will be virtual. So I'll have to hand over to our media team. As most of you know, Geoscience Australia started a new Exploring for the Future program, Phase 2. And as part of that, GA committed to do actually a geochemically sampling program throughout the units we encounter in our 25 drill holes. And David will give us an overview. They just started this year, and with COVID also having some issues, but he will actually give us an overview of what's going to happen in that space.
I'm going to, as Carmen said, talk about the baseline geochemistry project we're doing. It's still fairly early days, but we'll have a few slides at the end on metal sources and where they may be coming from, and also some work we did in the MacArthur region to deal with that same topic. So here's just a brief outline of the talk. So we'll just have a look at the basin-hosted mineralization module this forms part of. We'll have a look at the Stuart Shelf, what we intend to do. Then we'll have a look at the baseline geochemistry study, the methodology and current progress. You'll see we've been hindered a bit by COVID. And then we'll just have a look at some simple examples, unit characterization, looking at the Wallaroo, and then we'll have a play around with some source of metals. And so Wallaroo is an example. We've heard a lot about IOCGs maybe being the source. And then an example from the MacArthur Basin, which is much more mature. So this study we're doing here forms part of the Geochemistry for Basin Prospectivity module. As Carmen said, it's part of the Exploring for the Future federal government funded project. The main aims of this is to investigate mineral potential of selected Australian basins for obviously basin hosted mineralization, not just copper, cobalt, lead, zinc, silver, etc. And the broad long-term aims is to develop some sort of toolkit that people can use to enable rapid mineral potential assessment of the different basins. Round one, as we said, we did the MacArthur Basin, Mount Isa region, shown there on the right. And then this round two, we started on the Stuart Shelf region. And you can see they're both comparable sizes. I won't spend too much time on this. We've heard a fair bit about mineral systems. We're clearly adopt a mineral systems approach. It has a lot of advantages, as previous speakers have spoken about. In particular, the mineral system is often a lot larger, a larger footprint than the actual deposit itself. So it's easy to find if a mineral system may or may not have been operating within the basin. Importantly, as Susanna touched on, we need to know were they active, and not only were they active, but when. So here's the Stuart Shelf project, split into two modules. So the first one is the baseline geochemistry. So basically, we're trying to develop a regional geochemical characterization of all the Stuart rock shelves, not just the sediments, but the basalts, the base of the Stuart Shelf, and then into the underlying basement. We're looking in the basement, particularly for metal sources. Of course, we're integrating with the wonderful work that GSSA and CSIRO are doing. And then the detailed follow-up studies will be more data-led studies into the aspects of the mineral systems. So we'll let the data lead us there to where we want to go. So basically, the first part of this project, the broad aims is to get a large regional geochemical baseline or background characterization for all the units in the region. How are we doing this? So we're basically sampling all the units across the Stuart Shelf, north, south, east, west. We're sampling where we can, all the lithological variability within those units. And as I said earlier, into the basement. And as much as possible from drill core, and mostly the same holes that GSSA, CSIRO are looking at. And the aims, obviously the first one with the data is to produce an internally consistent geochemical data set. So basically analyze it to one laboratory over a short period. So they're all comparable and differences are meaningful. This will involve standard total geochem, so majors, traces, carbon, sulfur, but also selected organic carbon, FEOs. We're doing XRD as well to supplement the high logger, thin sections, MagSus, and also a bit of 4-acid work just so we can compare non-total geochem versus total. And This will all be supplemented with reanalysis of legacy samples. So we've just reanalyzed all the Jan Nuts and Ian Lambert samples that from the deposits that Stuart spoke about this morning, and we'll release that data shortly. And also we're compiling a lot of existing data. So as I said, we've had a few restrictions. We haven't been able to leave the state or leave the territory to get into the South Australia. So we've had to do a lot of our sampling remotely. So we've had to take advantage of the extensive high logger coverage and the core photos that come with those. We've also used the logging that Carmen's undertaken, plus the original geological logs. So you can see what we've done here. Here's the HODD3 hole that we've seen many times, over 1,000 meters through the whole sequence. And you can see the thermal infrared high logger faithfully reproduces all the units. So we can use the high logger to choose those intervals. And then we go into the core photos and pick out individual samples. And you can see just beside that thermal infrared image, we have all some dots and points. So they're the actual samples that we've taken. So in this hole, we've got about 55 samples that we've selected. So it's not ideal, but it's actually worked reasonably well and certainly helped by high logger. So where are we up to? So at the moment, we've sampled 22 drill holes. Those ones shown in red, and you'll see they largely coincide with the holes that Carmen spoke about this morning. There's a few extra ones that we've looked at, but they're mainly the same holes. We've so far, selected almost just over 900 samples. This is the distribution of those samples as we go down stratigraphy. So you can see starting from the top of the Wupina group down into the Umberatana and then into the basement. We've concentrated quite a bit on the Whyalla Sandstone and the Tapley Hill Formation for obvious reasons, but also Pandora and into the Beta Basalt and Backy Point Formation. We haven't got as many samples from the actual basement because there's a lot of pre-existing work done on that, and there's a lot of available analyses already. And we've had 350 samples that have been actually collected by our contractors that go into the Adelaide core facility, and they're just been submitted this week for analysis. So that's our data set. We're going to have probably about 1,000 new analyses, about a few hundred reanalyzed legacy samples, and then maybe 1,000 or 2,000 compiled literature samples. What do we want to do with that baseline geochemistry data set? The main thing is to characterize each unit, the lithological variability in that unit using the geochem. And obviously in the Stuart Shelf sediments, we'll link to the FASES mapping, the beautiful work that Carmen's done. But in the basement, we have to rely more on geochemical characterization. So I just want to give a little example of that. So here's the Wallaroo Grp, or basically Wandriara Formation and other sediments from the basement. So I've compiled a lot of this data. Most of it comes from GSSA. In fact, a lot of it's from Adrian's work, but also some of our own and company reports. And I've just got a couple of simple ternary diagrams there. So on the right, on the left, the more important one, you can see calcium magnesium on the top apex. So that's basically the carbonate component. SiO2 on the bottom left, so pulling out the siliciclastics, and then Fe2O3 picking out the iron-rich sediments. And you can see straight away that the Wallaroo group basically falls into three broad end members. So there's the carbonates shown in the blue stipple, the siliciclastics in the orange, and then the ironstones. And basically what we see are mixtures of those. On the right, it's the same thing, but this time I've just substituted in aluminium for calcium and magnesium. So this time we're picking up the shale component, and you can see this expands the siliciclastic field in orange from basically a mix between quartz, so high SiO2 into shales. So you can see we can easily and quickly characterize units using the geochemistry. We can take this further, of course, and look at it regionally. So here's the same two ternary diagrams, but now I've just plotted them up from north to south with different drill holes that we have the samples from. So you can see in the bottom plot, which are from the that PB26 sample in the very south up to EC21 in the middle section. Basically, the whole Wallaroo group is dominated by carbonates and some shales, so shaley carbonate sequence. Once we get further north into the region around Emmy Bluff and mineralisation there, we lose the carbonates totally for whatever reason and start to get into siliciclastics and a lot of iron-rich rocks. And then further north, we don't have a lot of data, but again, in iron-rich rocks and no carbonates. So we can see not only can we quickly divide them, characterize the unit chemically into lithologies, but we can look at those spatially. And of course, these units also vary as we go down the hole. And the other thing I want to say there, this is an interesting data set. It's quite lumpy, so we have a lot of samples from one area. This is the reason why we like to sample broadly and try and get as even coverage across the whole region. So it gives us a better picture. And clearly we're going back to get some more samples of this if we can. Of course, the whole aim of the game is to look at the mineral systems. So I just want to have a quick look at the metal sources. So here I plotted up some simple box whisker plots. So for those of you who aren't familiar with these, basically the area within the squares is where 50% of the samples fall, and then the tails go out either side. And then the anomalous values are delineated by the open symbols. So going from the top, you can see the beta basalt in green plus equivalents, again a dike swarm and butte metadolorite into Pandora formation in the browns, then into the GRVs, so Gawler Range volcanics, mafic and felsic, shown in blue for mafic, felsic is pink, and then the Hiltova suite, so the intrusive equivalents of that, and then in the Wallaroo. And you can see quite obviously straight away that the higher copper units occur within the basalts at the base of the Stuart Shelf sequence, and then also in the Wallaroo group. And we've heard a lot about Pandora, but it seems to be quite low in most of those metals. So of course, we showed that we had subdivided Wallaroo up into the 3 end members earlier. So we can actually look now at the copper contents and what they're doing with those end members to give us a quick idea of where the copper may be. And basically to read these plots, as you go from left to right, you're approaching that apice of the triangle. So the top one, copper silica, going towards more silica-rich compositions to the right. And you can see the copper clearly drops off. So it's not associated with the siliciclastics. And then the bottom one, which is the carbonates, again, the same thing. As you become more carbonate rich, the copper concentration drops drastically. And then in the middle, copper versus iron, and not surprisingly, given the IOCG mineralization and alteration in the region, there's a strong correlation with copper and iron, and the more iron-rich rocks have the higher copper up to quite high levels. So if the Wallaroo was going to be the source, you'd obviously concentrate on the altered mineralized parts of that system. But what we really want to look at is the basalts. So the basalt's traditionally held as one of the major sources of copper in many models. We don't have a lot of data as of yet for these ones in the Stuart Shelf. Particularly, we haven't sampled, or we've sampled a lot of altered basalts, but we haven't got the results back. So we just skip up to the MacArthur region and look at the basalts there and some of the work we've done there over the last part of the EFTF. So here's a simple same plot, just showing the whole sequence there now in the Lawn Hill platform area from the rift-related volcanics at the base of the sequence from roughly just slightly younger than 1800 million years up to 1600 million years. You can see all the different units that have been subdivided. And we've got a lot of data now on the metal contents of all those units. And there's just the 100 ppm line for each of those. And the interesting thing, as we'd expect, the basaltic units at rift-related basalts at the base of the sequence have the highest, in this case, zinc, is what we're interested in, and also copper. Another feature of this plot, which I won't go into too much, but you can also see at the top of the unit, there's some of the black shales here that have quite high metal contents. So this is actually also picking out where some of the metals are deposited. And in particular, that sort of pattern where you have a lot of the open symbols, so the anomalous ones, that's obviously from alteration. But if we look at the, if we think these basalts are the source of the zinc in the MacArthur and Mount Isa region, then we need to understand how regionally the basalts are they altered, is there evidence for zinc loss, etc. So we compiled a lot of data up there and then filled in the gaps by collecting drill core. So you can see the basalts here on the left-hand plot. So the greens are the older basalts, about 1790 to 1770, and the reds the slightly younger basalts, both rift related. So the basalts are extensive, so they're a good source rock. Are they altered? So this symbol, this plot, the symbols are sized according to K2O content. So the larger symbols have up to 6 to 12% potassium. So those people who know basalts know that particularly flood basalts probably have about 1% to start with. So these rocks are very strongly altered. So not only are they strongly altered, but they're strongly altered regionally. So we have a very large area of very strongly altered basalts and potassic alteration as well. So I've got the alteration. Do we see any evidence for metal loss? And the answer is, of course, yes. So here's just a simple plot, zinc versus K2O on the right there. And you can see that zinc contents drastically decrease with increasing K2O. So as the alteration becomes more intense, we lose a lot of zinc. So we probably started around 100, maybe 150 ppm zinc, and some of the more altered rocks are down to 20 to 10 and less zinc in them. Interestingly, in the older basalts in green, they also have evidence for zinc loss, but they go the other way. So that zinc loss is actually associated with chloratization. And in the Mount Isa, MacArthur region, the older basalts have a different alteration system from the younger ones. So we actually went through then, given that the regional nature of this alteration, and actually worked out just how much zinc may have been lost. And we basically did it, we basically did it for the southeast MacArthur basin there. So that green dotted line on the right diagram, we just used that area there. And we worked out that there's hundreds of millions tons of zinc that have been lost from the basalts. And there's some of the figures I've used there. And this compares with the deposits in those areas, particularly MacArthur River, but also the smaller Tina and Myrtle, which have a global resource of about 30 million tons. So you can see the basalts have lost a huge amount of zinc and more than enough to form the deposits, and probably enough to form many other deposits as well. So I think we've shown that in the mineral system sort of thinking, we've got an obvious plausible source for the metals. They're regionally altered, they're extensive, and they've lost a lot of zinc. And we can show that here. And the interesting thing from this study was the copper. So we also seem to have lost a significant amount of copper, probably similar amounts to the zinc. But this whole MacArthur Basin has very few copper deposits. There's Red Bank, there's a couple of small other ones, but they're not very big. So there's a lot of copper missing. Where is it? And we probably need to modify the mineral system up there. Probably do something like this that Adrian showed earlier from Hitzman et al. So hopefully I've just given you a bit of flavour for what we intend to do with the geochemical data set. So in the basin itself, we want to characterise the background values so we can see what's going on, but then into the basement and potential metal source rocks, we want to look at that and work out what or if, when they may have been operative. So obviously we're only in the early stages of this work for the Stuart Shelf. So we want to complete the sampling by mid-2022. Depends a bit on the contractors, but we hope to get that finalised by then. So I should have about 1,000 samples analysed, hopefully by mid-2022. The data, so it's not just geochemistry, but there's mineralogy, petrography. We'll be releasing as we go. The first lot of data to be released will be the existing samples, so all the Jan Knutson samples from Kapunda and Mount Gunson. They should come out shortly. And then the rest of the baseline data will be released as it becomes available. And we hope to have a synthesis report in the second half of 2022. And then follow-up studies will take off from there. So reports, data releases on various aspects of the mineral systems, particularly metal sources, but also fluid pathways. And we'd use a lot of isotopes. We may do some geochron. We're presently trying to date the basalt, the alteration in the basalts in the MacArthur region. So we'll continue there. And I think, yep, data and reports will be available via download from the portal. Before I say thank you, there's some links there that people want to look at stuff. The GA website, the Exploring for the Future website. You can download all the geochemical data via the portal. And there's some earlier extended abstracts we've done on the MacArthur Basin to give you an idea. And I'll leave it there, I think. Thank you.